radical review. Well, first, let's go from radical to rational form. So if I gave you something like square root of x cubed, remember, I might as well throw y squared in there. Remember, there's an understood 2 there, and it's always exponent over root. So this would be x to the 3 over 2 and y to the 2 over 2, which is 1. Because, remember, just your basic square root of x is just x to the 1/2 power. Cube root of x, x to the 1/3. 4th root of x cubed, x to the 3/4. And so if you have more to it, remember understood index of 2 if it's not there. Let's say 4th root of 2, x to the 5th, y to the 7th, c cubed. That would just be 2 to the 1/4, x to the 5/4, y to the 7/4, c 3/4. So that's how you go to radical to rational form. Now, let's go backwards and go rational to radical. So if I had like x to the 1/5 power, exponent over root, so that's just 5th root of x. X to the 2/3, exponent over root, so cube root, x squared. Even if I had something like x to the 1/4, 2 to the 3/4, that would be common denominator, so 4th root of 2 cubed, 8, x to the 1st. But let's say if they don't have common denominators, like 3 to the 6th, maybe x to the 5/2, y to the 1/3. Let's say they don't all have the same denominator, because we know that's going to be our root. Well, you can get it, because 2, 3, 6, common denominator of, 6. So 2 times 3, 5 times 3. 3 times 2, 1 times 2. So 6th root, 3 to the 1st, x to the 15th, y squared. Now let's simplify some. If I had square root of 18, remember I personally prefer ladders, but you can do it factor tree if you want. With ladders, remember, factor out any prime numbers. And then, since it's square root, you're looking for pairs. So you got a pair of 3's, a 2 left, 3 squared of 2. Let's say if you had square root of 72. So you wanted to try 3 first. 24, 8, let's do 2. So we got a pair of 3's and a pair of 2's. So multiply them to get 6. A 2 left over. Let's say you had a coefficient out front. You would just say 5 times 6, 30. Let's put some variables in there. 4th root of, let's say 12, x to the 5th, y cubed z. Let's leave out the 4th right now. So 12, break it down. So we've got 2, a 3 left. Now for the variables. Understood 2. So 2 into 5, 2 times, 1 left. 2 into 3, 1 time, 1 left. 2 can't go into 1. There you go. And of course, if it's cube root, you're looking for 3 of a kind. So if I did like cube root of 54 x to the 7th, that would just be, see, 2, you get 27. So cube root, so 3 of a kind. 2 left. And then 3 goes into 7, 2. 1 left over. Now, if you're adding or subtracting them, just like with x's, they have to be the same. So 4 square root of 2 plus 6 square root of 2, 10 square root of 2. But if you had something like 3 square root of 7 minus 2 square root of 6, those are different, so you can't do anything with them whatsoever. Now, sometimes what they'll do, though, is give it to you like this. We'll say 5 square root of 18 plus 6 square root of 32. Is that going to be what we want? Yeah, that should be right. That'll work. So break them down. So 18. So 3 square root of 2. So notice how that's actually 15 square root of 2. 32. 2 goes in there. 16. 8. So we got 2 pair of 2's and then 2 left over. So 4 square root of 2. So 24 square root of 2. 39 square root of 2. And the same if there's exponents, you can deal with them. Remember, if you're multiplying, if they're both in, you can multiply them. If you've got numbers out front, you can multiply them. If they're out, you can multiply them. If they're in, of course, the same index, you can multiply them. Let's say square root of 7 times 3 square root of 6 minus 8. 3 square root of 42 minus 8 square root of 7. You can even FOIL. Notice how square root of 6 plus 7 square root of 2 minus 4 square root of 3 minus 28. It's nothing you can do with it. But let's say square root of 5 minus 6, square root of 5 plus 9. Well, let's multiply it. Square root of 25, so 5 plus 9 square root of 5 minus 6 square root of 5 minus 54. Notice how since they have the same square roots, you can combine them. And 5 minus 54, negative 49. And similar to that, remember if they were to just give you something like square root of 2 minus 3 squared, remember you just write it twice and do the FOIL method. So that would be square root of 4, 2, minus 3 square root of 2, minus 3 square root of 2, plus 9. So 2 and 9, 11, minus 6 square root of 2. Now if you're dividing, it's the same principles apply when you're multiplying. If they are both out, you can reduce. Like 4 square root of 10 over 5 square root of 2. We'll make that a 40. Well, 5, can go into 40 8 times. And 2 goes into 10, 5. 8 square root of 5. Even if you had like square root of 24 over square root of, 32. Notice how 4 goes into both of them, so that leaves you, actually more than 4, 8 goes into them. So square root of 3 over square root of 4. And this one actually turns out nice since square root of 4 is 2. But let's say you have something like this, something that either you have reduced and it doesn't reduce anymore, and you can't get that radical out of the square root. Well, you have to do something called rationalizing. Since you've got a square root of 11 underneath, if you multiply the top and the bottom by square root of 11, that gives you a square root of 121, which is 11. And then just multiply. Square root of 55. Just like if you had 3 over 2 square root of 6. The 3 and the 2 you can't do anything with. Now the 2 is fine. It's the 6 you have to move. So 3 square root of 6. Square root of 36, or 6 times 2, 12. Reduce just a smidgen more. And remember, one's out, one's in, so cannot reduce. I don't think I gave you any of this, but I want it on the review because with the quarantine with Algebra 1, we didn't get to it. But like I said, I wanted it on this video because normally I would get to it right now. But if you have a plus or minus underneath, remember you can't just say square root of 2 because it makes things worse, not better. But if you multiply the top and the bottom by its conjugate, square root of 2 minus 9, watch what happens. Square root of 4, 2, minus 9 square root of 2, plus 9 square root of 2, minus 81. The outers and inners cancel. And with conjugates, they always will. So you can do the shortcut in the denominator, first minus last. Works every time. So up top, 3 square root of 2 minus 27 over 2 minus 81, negative 79. 4 over square root of 5 minus 8. So multiply by square root of 5 plus 8. So 4 square root of 5 plus 32 over 5 minus 64. 4 square root of 5 plus 32 over negative 59. And remember, it's got to be able to reduce in all, not some. So if you had something like 2 square root of 7 plus 10 over 14, yes, all of those would reduce. But if you have something like 4 square root of 3 plus 10 over 5, those reduce. Those don't. So you couldn't do anything with it. Now, let's say some radical equations. If I gave you something like this, remember with equations, your main goal is to get the square root of x all by itself. So if you square both sides, x minus 1 equals 100. Add the 1, 101. Just like if I had cube root equals 4, if you cube it, x plus 5 equals 64, 4 cubed. Subtract the 5, negative 59. Can even do something like square root of x minus 4 plus 7 equals 9. Get this by itself, so subtract the 7. Square root of x minus 4 equals 2. Square both sides. X minus 4 equals 4. Add the 4. X is 8. You can even have a coefficient out front. 5 times I will say x plus 1 minus 1 equals 14. Add the 1 to give you 15. And then before you square both sides, got to get rid of the 5. So square root of x plus 1 equals 3. Square it. X plus 1 equals 9. X equals 8. Now, if by chance you were to have a messier square root, something like this, remember, get the messiest one by itself. And then when you square both sides, you're going to have to do the FOIL method. So 64. Now, I literally just made this one up on the fly, so it's probably going to be ugly. Yeah, it is. Subtract the x's, so they cancel. You get negative 16 square root of x equals, subtract the 63, negative 67, divide by negative 16. There is actually an answer. It's just going to be terrible. And so when you square both of those, whatever 67 squared is, that would be your answer. Now, last but not least, just a quick graph. Square root of x, remember, looks like that. Square root of x minus 1, down 1, same. It's what makes it 0, so that would be negative 3. If you had something like, let's say, x minus 4 plus 2, right, 4, up 2. Remember, what makes it go down below is a negative. So if I gave you this, do this like normal, write 1. But the negative just means rather than flipping like this, you're going to flip like this. Let's say you had something like a negative x underneath. A negative x underneath, what makes this 0 is positive 4. But the x is negative, so to the left. If you have a negative negative, down. Hope this was of help to you. Have a great day. And as always, message me if you ever need anything.